protected, or we could do a spread footing with a wall with a slab that sits on top of that, and then it's all gravel on there. So, all depends on where you're at, what you're doing, okay? Then you have piling and girders. So piling and girders are, where we have bad soil, so we end up putting in what they call a grade beam. This grade beam might be, you know, uh, 18 inches by 24 inches tall, 18 inches wide, 24 inches tall. And we got these really strong grade beam that we ran rebar in. And then underneath that, they can either drive in piling. Piling is steel. You drive in the ground with a big hammer, hydraulic hammer on a piece of equipment. You can run it down pretty far, 25, 30 feet. You know what I mean? Or they can come in and drill holes, you know, and then pour those full of concrete. But the point of this is we're building a bridge to hold the weight, and we're putting legs down to good soil. Okay, that's really what we're doing. We're putting the leg down and through the bad soil. Hello. How many blocks? What's up? Huh? Yes, yes. It takes forever. Takes forever. Bye. Shannon didn't know what the answer is. So, that was a good quote, but I don't want to. Anyway, so we've went through, let's say this is bad soil. So we're bridging the bad soil with this grade beam, and we're taking the piling or the pier. This could be a pier if we're digging and pouring full concrete, and we're running down maybe 6 feet, maybe 10 feet, maybe 35 feet until we get to good dirt or bedrock. Okay, it's just another way of doing it. Pilings there's different types of pilings. There's pilings that you drive down until you hit bedrock. And then there's also what they call friction pilings. So you drive down until you hit a certain poundage. So, you guys ever use fence posts?
Yep.
So, if you drive a fence post in the ground with a driver, you know, sometimes you drive it real easy and it drives
You pound
all the way
it.
down 1, 2, or 3 times. Or sometimes, I mean, you just drive, it doesn't go on the ground, right?
You want wet soil.
Well, that's what happens with piling, is you drive it in the ground and you drive it until you get enough friction to hold the building. So in reality, it's not touching anything on the bottom. It just has enough friction on it to hold, I mean, 5,500 pounds or something like that. Whatever it might be 50,000 pounds, so that it doesn't move anymore. Now, of course, the fence post, when you're driving it into the top 12 or 15 inches of soil, what happens to that soil? Well, the top 15 or 16 inches gets saturated, so it changes. It also freezes and thaws, so it changes. But in reality, when you go to pull that fence post out of the ground, most of the time you got to really, really work your butt off to get that. That's kind of what happens with the pile. Except for we're driving it far enough into the ground that we don't have saturation of the soil, and we don't have freezing and thawing. We're all the way down deep, so that we've got a really good.
So there's no freezing in bedrock.
Well, it all depends on how deep it is, but if we run down that far, we should be good. And then the grade beam is what I showed you more on top of the pile. Okay. So frost protected shallow footings. So this is one way that you stop. ground, hey guys, what's the frost depth here?
Frost who?
Yeah, how deep is the frost here?
36 inches.
Oh, 16, 18 inches is as deep as it's gonna freeze here ever. I don't know that I've ever seen it 16 inches here. I've seen it 12, but I've never seen it 16 that I can remember, but I've dug in it at that time, of course, you got to dig like that. I mean, I've dug a lot of frozen soil, but, you know, it's been 0 for 3 or 4 or 5 days in a row, and I've dug into the ground and only got about 12 to 13 inches of soil that was frozen. So, what we tend to do, this is one way, what happens if water when it freezes? 9%, 9%, that's important. 9%. Reason why it's important is if it expanded 1%, it wouldn't really be that big a deal. But when something expands almost 10%, if you get water under the edge of your foundation and it freezes, your whole building picks up, your floor cracks, you have major failures. Okay? So, in order to combat that, if we have a shallow footing, we put insulation on the outside and then we put insulation out away from the building. That way this freezes. This insulation stops it from freezing down deeper because the ground is naturally 50 degrees. So typically the ground, that's the reason why we don't freeze deeper than 16 inches here, because we don't get cold enough. The ground has its own heat. So, we put that insulation in there and that keeps the ground temperature below this from working underneath that and freezing underneath the foot. Have I ever actually seen anybody do this? Why? Because we're only 16 inches. Wouldn't it be a little bit cheaper to just dig a little bit deeper and pour a little bit more concrete, digging out a bunch of dirt outside of it, and just getting down below frost level? Yes, it is. But we're talking locally. In Chicago, frost depth is probably 36 inches. Now, we have to dig a lot deeper, and put a lot more concrete in it. Now this is probably cheap. You get into Wisconsin, you might be 60 inches. Northern Wisconsin, the frost depth might be 60 inches. Alaska, the way we build changes for where we're at. And that also goes for this types of foundations. We want to pick our foundation based off of our site and our frost depth and all that kind of stuff. So does it make sense to do a crawl space in Wisconsin? If I have to go 60 inches deep, I'm pouring, and I'm gonna stick out of the ground 12 to 15 inches because I want to keep the dirt away from the wood. I'm basically pouring a basement anyway. So why not use that as a basement? Will it work as a crawl space? Yeah, but if I gotta dig 60 inches deep, I might as well put a basement. There's very little cost there, let's put that way. Very little cost.
Get some extra square footage is what you're saying, so the value goes up.
Well,
Property value goes up.
There's no reason not to. It's the same cost, it's cheap. Now, on the opposite side, do we see very many basements in Florida? No, because we can literally pour on top of the ground. The frost depth is probably still 10 inches, is probably what they're still calling it, because the sand will probably freeze really easy. But on the same hand, they don't really worry about freezing thaw down there because the water gets out of the soil so fast. They're not worried about the water freezing. Now, I will tell you that when it does hit 30 degrees down there, there's massive water line breaks because they run their irrigation out through the yard 3 inches deep. They don't worry about they got pipes on the outside of their houses that aren't even, it just doesn't get to that temperature very often. Here's a funny story. In Austin, Texas, it normally doesn't get really, really cold. one guy said he had 250 on houses that he had built that froze. Because they don't worry about it, they don't even think about it. None of those lines were insulated, they were just outside. So, we have to build for the area that we're in. So in Florida, we bore slab on grade. Monolithic, no footing, no spread footing, we just put it right on the sand. Here, we're typically crawl space, some basement, and we do have some slab on grade, we're in that, we get to kind of see a lot of everything. You get the further north you go, the more basements there are, the less slab on grade there is. Because it's expensive to dig a trench 40 inches deep full of concrete. So we get away from it. Here's some footings. Here's a foundation wall sitting on the footing. If you look here, there's a keyway. Keyway is a mechanical lock to keep the wall from sliding back and forth. We don't really use them as much in Southern Illinois as they do in other places, but we can also use other mechanical locks like rebar out of the footing to go up. But this also helps stop water from going through because there's a low spot in it. But hydraulic pressure will always push through unless you have some type of called water stop. Actually, we're a rubber water stop where it goes 3 inches down into the footing. It goes 3 inches up into the wall, and some concrete goes all around it, and then it's actually got a rubber seal in between it. A lot of times we'll do that vertically in a wall when we have to stop or two walls together, put that water stop in it. But there's a keyway, that's for the mechanical. Here's a step footing. So if we're on a slope block and we're putting in the crawl space, there's no reason to have a I only want to be 9 inches out of the ground up here, okay? I'm for my floor. But maybe it's 4 feet back here. So there's no reason for me to go and dig out all of this dirt. So we'll just come out here and do a step footing. So we're not digging all the way down this bottom footing like that. So we're not digging all of this dirt out that we don't need to dig out. We only need to be below the frost level. So we just dig a step footing. Typically, steps are done in 8-inch increments. Anybody know why? 8, 16, 24 increments. Because that's what blocks are 8 inches. Typically, you do step footings with blocks.
CMUs?
Yep. By the way, she had estimating class last semester, she got us in. So a block is called a concrete masonry unit. A CMU. So typically, we're gonna do that because concrete forms are in 2-foot increments. And also, it's a little bit harder to pour a concrete wall with an out-level foundation. You're end up using plywood or something like that, which is expensive, time-consuming. So if we're pouring a wall, typically, we'll try to get our footing flat. Reinforcing, normally we'll run 1 to 3 bars in a footing, lengthways, and then sometimes if you have a thickened footing that's wider, maybe you got something like in this case here, maybe we've got a fireplace that's gonna sit on the inside, so we need a wider footing, we'll run crossways. So this is slab on grade. actually pour the footing and the floor together. Monolithic is the word, mono meaning one, so monolithic slab.
Meaning flat, like no elevations in the slab. Mono being flat,
No, mono meaning one pour.
one pour,
So
flat.
we pour the footings and the floor at the same time.
Okay.
So if you look here, this is not a very good picture, but here's the footing and the stem wall, and there's a thickened spot, and there's a footing and a stem wall that's going down. This is the top of the flat slab. We pour it all together. Where do we do this at?
South.
Well, yeah, but where do we wanna do this in warmer climates, not really cold because it gets expensive. It can be done anywhere. We can do this in, Alaska. But it gets more expensive because we gotta get below the foundation line, or we gotta do that insulation where we're insulating the ground. But we also do this where we have decent soil. Where we have consistent soil, like in Florida, I wouldn't call that decent soil, but it's all the same. So it doesn't really matter where we're at, when we pour it, it all flows together. The monolithic slabs are very good for earthquake and bad soils. Because in an earthquake, what happens? Anybody know?
They crack?
Yeah.
The ground moves.
The ground becomes liquefied. Okay?
It bounces?
Basically, yeah. And a monolithic slab becomes a raft. It just kind of floats with it. It's all together. Unlike, spread foundations, spread footings and walls, these aren't poured together, so there's a weak spot right here, there's a weak spot right here. In this case, when all of this goes, it can all move separately and come apart. Where a monolithic slab, which poured with rebar, matting and everything else, it just kind of floats like a boat up on the road. So it's very good for bad soils. As long as you don't need to go deep, okay? When you start getting deep, it becomes more expensive. Because, well, think about it. If I'm digging, if I need a 2-foot wide footing, in this case, I've got 8 inches of concrete with a 6-inch slab underneath. If I had to have this type of weight distribution, and I was doing a monolithic slab, I would have to have 2 foot of concrete all the way down. Does that make sense? Because I'm not forming up a wall. If I'm pouring monolithic, the whole trench would have to be full of concrete. So I'm tripling the amount of concrete that I use in a monolithic slab for my wall. So once this gets, in my opinion, deeper than 24 inches, it starts to become not cost effective. And the 24-inch line is, so basically, once you get to Effingham, we start looking at this like this isn't really cost effective. Because Effingham has about a 24-inch crossing depth. But anywhere south of Effingham, this can be efficient if it works for what you're doing. We can put wire mesh, rebar in the concrete. Here's some footing forms, and we're gonna do some footing forms in lab here after probably starting next week. So you come in and we're gonna set an outside form and then put a spacer and set an inside form and probably pouring concrete we have to do. I'll show you how to do it. Basically setting concrete forms. Here's a column form. It's the same as digging a footing. Now here is a down view of this, and this is actually former drain that's here, and it's not wood. Can't really see it on the screen very well, but former drain size as like a 2x6, except for it is plastic and you don't remove it. It's got little slits in the outside of it, you put rock up against it, and the water goes into it like we were talking about the drain tile. So, if we put a drain tile down, we put rock all around it, the water runs through the rock and then goes to the drain tile and goes out. Well, with former drain, you don't need the drain tile. You buy the former drain, it's plastic, it's got holes in it, it connects from the inside to the outside. You put rock all around it, the water goes into the rock, it goes into the drain, and the former drain, and then it goes out through the former drain. So you're kind of doing two things at once. It's a very good product. It can be a little bit more expensive, but what's really neat about it is you can put pipes from the inside to the outside. So now we can remove the exterior water. The interior water is the exterior drain. And also, you don't have to remove it. So you can set it in there, you can backfill the rock, and then when you pour the concrete, you're done. So it saves a little bit of labor. It definitely saves labor whenever we're talking about coming back and having to put in the drain collar on the outside. But you gotta run the numbers on this stuff, on whether it's really cost effective. Sometimes, the labor is cheap. People always think labor is super, super expensive, but some things only take minutes to do. That makes sense. You still put rock in it, it only takes a couple minutes to lay the drain tile down. So, now, it does, sometimes depending on the basement, it might take a couple hours to remove forms. So you might pick up, $600 there, which might offset the cost of the form drain. That's part of management, is looking at all this stuff and trying to figure out the cheapest, most effective, because sometimes, if we're on rush schedule, time is worth more than money. Sometimes if you're not on a rush schedule, it's just whichever one's cheapest. So this is one way to build forms out of plywood. I've never done it like this. I don't like it. I would never do it. I don't recommend you doing it. But it will work. The reason why I say that is, first thing, I'm not a big fan of plywood forms at all. And there's a lot of cutting, there's a lot of wasted material here. There's a lot of wasted material. In other words, I don't mean wasted. What I mean is non-reusable materials. Unless you're doing this for a living, you're more than likely, this board is now scrapped, this board is scrapped, this board is scrapped, and possibly this vertical board is scrapped when you're done with the job. So you bought all this material, you're throwing it in the trash. Now, there's better ways of doing it. Here is, alright, so this is a different way of doing it, where we're using, these are wall ties that go through the forms, and they have what they call a cat head that goes on top of that style, and a pin. You put a cap over it, you drive it down tight, it's got a pin that goes through it. This is what you would consider to be an internally supported form. The other one that we just looked at was an externally supported form. So in other words, the first one we looked at, we were kicking braces on the outside, right? We had board here, we had board across the top, okay? So we're supporting everything from the outside. Well, the problem with that is the deeper this goes, the more hydraulic pressure's on it. So even if it's an 8-inch wall, if it's 10 feet tall, there's a massive amount of external pressure going onto this thing. Massive amount. Put it this way, I poured a 4-foot wall, and I put a bunch of bracing on it, did a bunch of stuff, and I parked a bobcat up against it.
To keep it from collapsing?
Huh?
To keep it from collapsing?
Keep it from moving.
Uh-huh.
And it moved the Bobcat, blew it all, because, and that was only 4 feet. It's probably one of the hardest things, in my opinion, to do, and I've poured a lot of concrete, guys, you don't realize I've poured a lot of basements, a lot.
Retaining
This is
walls
very different.
are all made like that though.
What?
How are retaining walls made? Like that with forms?
This is one way.
Okay.
So this is externally supported. Now, internally supported is the best way. And the reason why that is, which is this style, where you have a tie that runs through the middle. Now, all of the pressure that's pushing this direction is equally pushing that direction.
With rebar tie? Sorry.
Those ties that go through the
Ties, sorry. Wooden? Just wooden?
No, it goes all the way through the thing, tied on both sides. So when you have a steel bar, which is a tie, that runs in here like this, and you cap it on both sides, so it can't go anywhere. Now, the same amount of pressure is on the inside as is on both sides of the thing, so it's equally pushing out like this. So it's actually holding itself in place. Internally supported is the way to go. Because all of that hydraulic pressure equals itself out. That tie is going to stop it from coming apart. And the pressure pushing this direction is equal, so it stays in one spot and doesn't move. Unless you vibrate it or do something. So these are panel forms. We're going to set up a basement out in the shop. We've got some panel forms. Panel forms are an internally supported form, like what we just said. They come in all different widths. Typically a 2x8 is the most common, 2 foot wide, 8 feet tall is the most common for a basement. Every one of these joints, so this is a brace, this is the form. So this area right here, 2 feet wide is the form, this is another form. These are braces going down. So on every one of these vertical seams, about every 18 inches, you have a steel tie that ties the inside to the outside. And we'll go through all this and I'll show you all. It's prefabricated, it's very easy to install. I probably put in 200 basements with this form. At one time I had 3 semis that had semi-trailers, and they were all over these forms. We could do, I think we could do 4 to 6 basements, depending on the size of the basement. We could do, I think we do 6 30 by 40s at one time on different spots. Really, really, really good stuff. Expensive. And we'll go over this out in the shop a little bit. This says recheck formwork. Before anything, when I was using those basement forms, the entire crew, didn't matter how big the crew was, there were 10 people on the job, the entire crew checked every pin on the job. And I'll show you what pins look like. I got one.
So they'll milk it and go into the